Hello everyone. So let's discuss the paper 2. So if you compare the depth and the number of questions and other aspects of the questions, means like the ease of the question and the depth of question. So it is almost similar to what is that of paper 1. So there is no much difference. So similar number of questions has been asked and similar pattern is being followed. So you don't have to worry if you write paper 2 or paper 1. So you can say it's equally easy or equally difficult compared to paper 1. Okay, so let's go to the details. So we have about 16 to 18 questions from this topic, materials manufacturing and industrial engineering. Maybe the majority of the topic, majority of the questions are coming from this one, right? So let's discuss one by one. These first two questions, you can claim that it is a part of other subjects as well, like your strength of materials or your design, machine design. But still, since it's coming in the materials part, so that's why I'm discussing that too. Okay, so which of the following is the definition of ultimate tensile strength obtained from a stress strain test for a metal specimen? The choices are the stress value where the strain curve transformation of the elastic to plastic behavior, the maximum load attained by divided by the original area of cross section, the maximum load attained by the corresponding instantaneous area cross sectional area, and the stress where the specimen fractures. Okay, so what is the first one? The stress value of the stress strain curve from elastic to plastic behavior. So that is our yield point, right? So this is our yield strength, yield stress, yield strength or fracture strength, right? Right. But what is the ultimate tensile strength? Now you have only left with two options where we have to divide both the options are similar. So it's the maximum load attained divided by the original area of cross section or the instantaneous area of cross section. So you can see that your ultimate tensile strength will come only in your engineering curve, not in your true curve. Okay, so if it's this drops, it will keep on increasing. Okay, because your area is going to be down and your stress values, means the force that you are applied is remains constant. If it is remains constant, okay, and your area is going to be down, that's why it will keep on increasing and fractures at the point. This point is corresponding to. So here will be what we observe as your ultimate tensile strength, UTS, you can say. UTS, right? That's what we used to call it, right? The strain corresponding to this point is also, or we know all the properties of what is the significance of this thing. Okay, after which your stress is going to be down. Why it is going down? You will not see the drop in your force because your area of cross section, because means actually even though your true strain value is going high, your engineering curve will go down because we are considering not the instantaneous area of cross section, we consider the actual area. So whatever area we have for this first initial area, we will consider that to compute the UTS, right? So UTS is coming. There is definitely there could be a point corresponding to UCS in your true curve as well, but that is only, we will not call it as UTS because it will come in the engineering curve. So we will use the original area of cross section, not the instantaneous area of cross section. So this will be the answer. Okay, well, pretty easy question. Okay. Now the second one, so this is from the failure theory. But we have not, means it's you can say that it's a part of in your metal forming chapter, you will come across this failure because you have to see how the material failure is being, means if you want to make an FLD failure forming limit diagram, so this kind of theories could be of course used. Okay, and it's an important thing in terms of your machine design. Okay, so that's why I have, since it's coming as part of its forming, so I will include this one. So this is saying that the structural member under loading has a uniform state of plane stress. It's a plane stress condition, which is usual notation is given as sigma x is 3p, sigma y is equal to 2 minus 2p, tau xy equal to root of 2p, root 2p, you can say, where p greater than 0. The yield strength of the material is 350 MPa. If the member is designed for maximum distortion energy theory, then the value of P at which the yielding starts. So it is asking the value of P when the yielding starts. Okay. So we assume that we will so distortion energy theory is nothing but our 𝐕-3, right? So in the 𝐕 criteria, we assume that your 𝐕 stress is all the 3 axial stresses and also the shear stresses. Then the total formula will be coming back x minus sigma x minus sigma y whole square plus sigma y minus sigma z whole square plus sigma z minus sigma x whole square plus 6 times tau xy square plus tau yz square plus tau xz square, and this will be under root. This will, if it is 6, it will be under this root. Here it will also be root. Then you have to take 1 by root 2 under this one, or you can take 1 2 into this side, and you can say it's 3 and 2 here as well, right? Now, what will be this one? Now, so this is the total equation. So here we have only x, sigma x and sigma y. Sigma z we can assume 0, and the other tau value is also 0. So what will be the 𝐕 stress? So this will, I will take this inside. So this will be sigma x minus sigma y. So sigma x is 3p minus of minus 2p. It will be 5p square plus sigma y minus sigma z will be sigma y only. Sigma y square means 2p square, because even though when it takes minus 2, let it be there. Okay, plus sigma z minus xy again minus 3p whole square plus 6 times tau xy is the only thing. So tau xy whole square. So it will take the whole under root, right? So it will be how much this will be tau xy is root 2p whole square, right? So this whole divided by 2, and of course this will be under root, right? So this, okay, it is this is also in under root. The bracket will come in, so this will be right, fine. So this will be how much? This will be 5p square, 25p square, 4p square, 9p square, plus this will be 12p square, right? Divided by 2 under root. This will be 9, 25 plus this will be 13, 29 plus 9, 38 plus 2, 50 plus 1, 60, 60 by 2. No, it's 50. 50 by 2 will be 25. 25p square. Root of 25p square will be equal to 5p. Right. Again, let me calculate 25. This will be 13 plus 25. 13 plus this one. No, this will be 13 plus 12 will be 25. Right. 25 plus 25. Yeah, 50. So 5p will be the answer. So this it's saying that when yielding starts, so this will be equal to our strength of the material is 350p. So that's what it says. So sigma 1, sigma var. So this is 𝐕 stress. So sigma y should be greater than or equal to. This is the condition for your failure. So if you want to express your yielding as your failure, so this will be the condition. So if I if I take the equality constraint, so this will be 350 will be equal to 5p, and your p will be equal to 570. 70 MPa you will get. Okay, so anyhow the answer is there. So this will be your answer. Okay, I hope that I didn't make any calculation errors, so you can correct that thing. Okay, so this is the anyhow the other teachers will tell you in details when it comes to your strength of material course, not your machine design course. Okay, fine. So let's move to the core subjects. So this is from our material science. Okay, and this is also pretty straightforward, but there is slight understanding has to be there. So what it says, the fluidity of the molten alloy during the sand casting depends on its solidification range. So we know that alloy is not having a particular solidification melting point, so it will be solidified through a range. Okay, the phase diagram of the hypothetical binary alloy of components A and component B is shown in figure. It's a eutectoid combination composition and its temperature. So it's a eutectoid reaction. So one liquid changes to two solids, right? So it's a eutectic, right? So liquid changes to alpha and beta. Okay, and this is the known as the eutectic point, and this is known as the eutectic temperature. All lines in the phase diagram, including the solidus and the liquidus, are straight lines. That's another category. So all the lines are straight lines. If the binary alloy with 50% weight B is poured into the mold at the pouring temperature 600, and then the solidification range. So if I'm taking, so this is the composition of B in A, it is given, right? So if I'm taking 15% of B in A, and its temperature is 800, anyhow it's above both, means above the liquidus, right? So 800 is above, means all the temperature at that point. So at that point this will be the temperature. So this will be the starting of your. So what will happen if I take this point? So what will I have? I will be having only liquid, right? And I'm reducing the temperature, and when it reaches this point, what will happen? Our solids will start forming. Our nucleuses will start forming, and by this time you can see that by whenever I'm still the liquid will be there in this region. You will see alpha plus liquid, right? And again I am going down and down and down and down and down till I reaches this point. There will be liquid, and after this point, what will happen? You will only have solid, right? So this is the thing which is asking. So what is the range of temperature of solidification? So this range it is asking, right? And for calculating this range, it is very simple. We have given the thing that all the lines are straight lines. So we can use the interpolation to find out what is at this point, right? What will be this point? Suppose I have two y. Suppose if this is my y value and this is x values, you can see that from just looking at itself, you will understand what is this value, right? This 0 to 30, and this is 70, means 400 to 700, and we want to find out exactly at 15, right? So whatever is the half will be there. So half means not the half for the lines half. Lines half means it's 700 to 400. So it will be the half means the total this thing will be 300. The half will be 150. So it will be 400 plus 150 or 700 minus 150. So it will be 550. Or if you want to use a line interpolation, you can say that x, suppose if I'm taking this x, so x minus x1. So x1 will be, this is the 1 point, this is the 1 point, and this is the 2 point. If I take x minus x1 means x minus 1 point, the corresponding value will be 0, divided by x2 minus x1 will be 330 minus 0 will be equal to y minus y1. Y is y we want to find out. Minus y1 is 700 minus 700 divided by y2. Y2 is 400 minus 700. So let's say this will be 50, this will be 30, and this will be 1 by 2, and this will be minus 300. If I take minus 300 by 2 will be equal to y minus 700. If I take this on this time, so this will be 700 minus 150. That will be the y point. So this will be 550. 550 degrees Celsius is this point. Now you know that this is 550. So your solidification starts at 550 and exactly ends at 400. Now what is the range? The range will be, say, it's a question which can make you confused. So the range will be from, you can say that it will be 550 to 400. That is actual range. But whether they are asking at what point it is completing, right? But no, that's not what is asked, right? It is a range. Range means what is the difference between this temperature? If that is the question which is asked, then your difference will be 550 minus how much? 400 will be 150. 150 will be the answer. Or if they are asking exactly what will be the what is the limit of solidification range, then the answer would be 400. Some of our friends might have misunderstood this one. So the answer, the apt answer for this one will be not given, which is not given. So actual answer will have been 550 to 400. That's for true, right? Since that is not given, you can say that that range can be expressed like the difference between this thing, and you can say that it will be 150. Okay. Another question. This is from metrology. Okay. So a shaft of diameter this much is assembled with a hole of diameter this much. Match the allowance and limit parameter of column 1 corresponding to. So it is given us match the following with 3 things we have to find out. So the shaft is of this dimension, right? Let's make the shaft also. If 25, this is my baseline, this is my 25 line, 0, 0, right? And my shaft is less than this one, so it will be, this will be 0.4, 0.04, and this will be 0.07, right? What about my hole? Hole will be the lower limit is 0 and my upper limit is 0.2, and this will be my hole. This is 0 and this is 0.02. Okay, this is hole and this is shaft. So what kind of fit it is? Hole is bigger, shaft is smaller, so it's a clearance fit, right? So it is asking, first thing is allowance. What is allowance? Allowance is nothing but the difference between the material limits. Allowance, let me write allowance. Difference between the material limit. Oh, difference between the maximum material limits, you can say. Maximum material limits. Okay. So what will be the maximum material limit for a hole? For a maximum material limit of the hole is this one, right? It will be the lower limit of the hole. And also, okay, you can say that it will be lower limit of the hole is the maximum material limit. Or the hole diameter is, yeah. Minus, so that is the maximum material. What will be maximum material limit of the shaft? So when will the shaft will be maximum? When it is having the upper material limit, right? So upper limit of shaft. So lower limit of the hole minus upper limit of shaft, because this is the maximum material limit of the hole. So hole will be maximum, means the material will be maximum when the hole size is 25.00, not 25.02. So then the material is less, right? So this is the definition of allowance. So what will be this one? Lower limit of the hole. In this case, it will be 25, right? 25.00. Minus upper limit of the shaft. Upper limit of the shaft is this one. This limit. This is the one, right? So what will be that? That is 25 minus 0.0004, right? So that what will be my allowance? 0.04 mm. So this will be the first one. We have find out, right? What is the maximum clearance? From this one, you can see that when the clearance will happen. So maximum clearance is when your hole is at this point and your shaft is at its lower point. The hole is at this higher point and but the shaft is at its lower point. So this distance will be the maximum clearance. This will be the maximum clearance, right? So how much it will be? It will be 0.2 plus 0.7. It will be 0.9. Right? You can see that this in this side it will be 0.2 and this side it's 0.7. So that will be 0.2 plus 0.7. It will be 0.9. So we also have the second this thing. So maximum clearance will be 0.9. Now maximum material limit of the hole. Maximum material of the limit of the hole is already we have specified, right? So what will be that? That will be the lower deviation of the hole, lower limit of the hole. So that will be this one, 25. So do we have an answer like P equal to 4, no, P equal to 3, Q equal to 1, and our R equal to 4? So yeah, first answer will be this, right? Right. So it's very simple problem, but only 3 things you have to find out. And if you have a good knowledge about metrology things, you will simply able to do it. Okay, I think there is no confusion. Okay, let's move on, guys. So this is from our additive manufacturing module, right? So in the additive manufacturing, it is asking to have a match the following. So it is giving you the one side, it is the manufacturing techniques. The another side, it is the input material. What kind of material we use? Fused deposition modeling, laminating, object manufacturing, selective basic sensitive. The object which is used is photosensitive liquid resin, heat fusible powder, filament powder, sheet of thermoplastic or green compacted sheet metal. So the fused deposition model, so that is generally known as 3D printing. Okay, where we will use the filament of polymers or plastics as the raw material. So one will be this one, 3. Laminated object manufacturing is you will be having the sheets or laminates of thermosetting plastics or the green compacted sheet metal, and you will cut those laminates using a sharp knife, and then you will stack that thing. Then you will make that thing melt, and the bonding will happen. It's not complete. It will be only centered, you can say. Okay. So the laminated object manufacturing uses the sheet or thermoplastic or green compacted sheet. Now, what about selective laser sintering? Selective laser sintering, you will be having a laser head where you will use powder as your raw material. So heat fusible powder will be the raw material. Okay. And suppose if the stereolithography was there, then you will use the photosensitive liquid resin as the raw material. Okay. So this is the choice. P will be 3, Q will be 4, and R will be 2. So again, the first, this will be the answer. P will be 3, Q will be 4, and R will be 2. I hope it's very politically. So one question from each paper it is coming from this additive manufacturing. Okay. Now from CNC, which of the following cannot impart a linear motion in a CNC machine? So we knew what are the things which can be used for giving a linear motion. So linear motor, of course, we can use it. We can use a linear motor. Bolt screw, of course, we can use bolt screw. Bolt screws are generally used. Okay, if you don't want a higher backlash problem, then you can use for lead screw will be having a backlash problem. To eliminate that thing, we use the bolt screws. Pre-tension bolt screws we can use, right? And which will be more accurate. So lead screws, of course, we can use lead screws, but control means that accuracy will not be that much compared to the bolt screws. But chain and sprocket. So chain and sprocket, where you will find in cycles or scooters, bikes, kind of things, you will see the chain and sprocket, right? It can be used for transmitting power, but it is not also. It can be used for converting some motions in the linear direction. So it will not be used for convert in a CNC. Why? Because the control is very, very limited, because there will be a lot of error which can happen when we use this kind of arrangements. Also, the transmitting efficiency will also means the efficiency and the power requirement will be means the load which can take by this chain and sprocket mechanism is also limited. So we will not use the chain and sprocket mechanism in CNC machines, and we have not seen that, right? So D will be the answer because it is asking which is not used for this thing. So chain and sprocket will be the answer. Other 3 can be used in CNC machine. Another question. Okay. I hope means in the first go I was thinking like it's a multiple choice question, but I feel that it's a multiple selection question. I'm not quite sure. Anyhow, we'll solve this thing out, and we will find out the possibilities. Right. So it is saying that considering it's from the sand casting problem. Okay, cube of edge A. So we are casting a cube of edge A, and a cylindrical laser is placed on the top of the casting. So assuming the solidification time is proportional, T is proportional to V by A, where V is the volume and A is the area of cross section. Cross-section area of the dissipating heat. If the top of the riser is insulated, which of the following radius or radii of the riser is acceptable? I think here is the catch, is or R, which means that there are multiple options are there, right? If there are multiple options, let's solve this problem. So so there is a cube. Okay, so the cube is there. Okay, and above the top we have a riser. Why riser is a cylindrical? Okay. Now this edge is A, and we don't know the dimensions of this one, right? But we know that this surface and this surface is not going to, because this is insulated, right? So there is no heat transfer happening in this surface. Anyhow, it's the top riser, and we are placing on the top, which means that this face is also not going to take part in heat transfer. So only the peripheral face, the curved face, will have this heat dissipating capability, right? Now, what will be the formula? So what will be the V by A of this? So our objective is the riser has to solidify only after the solidification of what you're casting. So that is a mandatory condition, right? So your T, your T of casting should be less than, means T of riser, right? So riser should only solidify after your casting fully solidified, right? Sometimes you can say that equal constraint can also be put. We will see whether to put it or not, right? So for the sake, we will put it. It's purely greater. Fine. So what will be T of this Q casting? You can say how much it will be. So V by A, which will be volume will be A cube, and what will be area will be 6A square. So this will be A by 6. Okay. What is TC of riser? TR. What is TR? Riser has only, I said this is the circumferential area. So still the volume will remain the same. It will be pi by 4 d square h. So what will be the area? Area will be how much? Only this circumferential area we will consider. So that will be pi dh. So here h and h get cancelled, d and d get one of them get cancelled. This will be, so it will be nothing but d by 4. So we know that TC should be less than TR, which means that A by 6 should be less than that of D by 4, right? So what will be D by 4? D by 4, which will be nothing but R by 2. If I taking in case of radius, so it's asking in the terms of radius, right? R by 2. So A by 6 should be less than or equal to R by 2, which means that R should be greater than or equal to A by 3. R should be greater than A by 3. Okay. Now coming to the options. So A by 3 is there, A by 2 is there, A by 4 is there, A by 6 is there. So taking this in the first go itself, you can eliminate two possibilities. I should be greater than A by 3, right? So when it has to be greater than or A by 3, then you can eliminate the possibility of A by 6. You can also eliminate the possibility of A by 4 as well. Only two choices are left. But should we consider the equality sign or not? That is the first question, right? When we consider the equality sign, suppose your riser and your this thing is solidifying simultaneously, will it compensate for the shrinkage? Actually, what to say? It can or it cannot. It will be related by some other, the different factors, whether it will because of the shape of this thing and all the thing. But there is a possibility that this could work. There is a slight possibility that this would work. So I don't know whether IIT Kharagpur will accept this thing or not. Otherwise, the answer will be only A by 2. A by 2 will work because then it will be R will be greater than A by 3, right? A by 2 will work. Suppose A is equal to 1. What will be A by 2? It will be 0.5. A by 3 will be 0.33, right? So this satisfies A by 4 will be 0.25 and A by 6 will be 16.16 or something. So these are not the answers. This could be an answer and this could be answer. So since it's a multiple selection questions, since this slight possibility remains, then you can also opt for this one. So the answers will be A and B. If you are following the strict rule, like it should be greater, then you can have only one answer, that is A by 2. But it is not in my hand, it is not in your hand. IIT people has to decide, and I don't know what kind of answer they will give. I probably, since there could be a debatable thing, so probably both the answers will give. But the other thing is that since it's a multiple selection questions, you will get only right answer when if two choices are there. When you make the two choices right, then only you will get the correct answer. Anyhow, there is no negative mark. So still, it's a debatable thing whether to give only those who get all these the two ticked or two right answers will get the marks, or any of this only the person who write this one get the marks. Okay. So anyhow, this is up to them, and when the answer key comes, you will know what will be the answer. Okay. I hope this is not a big problem, but a slight confusion is even for me. Okay, let's go on. Now, which of the following involves melting in metallic workpiece? Okay, so first thing is given electrochemical machining. Then second thing is electrodischarge machining, laser beam machining, electron beam machining. Okay, so what is that is the material removal option in electrochemical machining. It will be in form of ions, right? It will be dissolving to the this thing. So the reduction will happen. Okay. So it's a dissolution will be the mechanism of here. So do we, I mean, say the metals are dissolving doesn't mean that it is going to the liquid form. It's going in the form, atomic form, it is moving, it means dissolving, right? So there is no melting happening in electrochemical machining, right? So this will be one answer. Now take the case of electrical discharge machining. Is the material answer? Okay, this is not the answer. Okay, this is the wrong answer, right? So in electrochemical machining is no material melting will happen. Melting will not happen. It is more. It is the material is getting dissolved in atomic form and also not converting it into molten form. It will directly it will directly go to the dissolve. It directly get dissolved and it's gone, right? Electrical discharge machining. So they will be having erosion. Erosion, you can say, right? This is nothing but melting and vaporization. So when the arc hits the your electrode or your workpiece, what will happen? Your slight amount of material will be evaporated, but it will happen only after melting. Melting and evaporation is the thing. So here, this could be one answer, right? In electrical discharge machining, the melting will happen for a small amount of time, or very small amount of time and very small amount of material is happening. But we will not able to see the melt as it is, but still there will be melt. Laser beam machining, of course, there will be melting, because here also the same mechanism, high beam of laser is impinged into the workpiece and it is melted and vaporized. Okay. Electron beam machining is also even, it will be even stronger beam is there compared to the laser beam, so that high amount of energy is concentrated at a particular point, so that the material melts and evaporates. Okay. So the answer will be, since it's a multiple choice selection question, you can say that answer will be B, C, and D. If you get all the three, then only you will get the marks for it. I hope that you all might have done well. Okay. Now, industrial engineering. An electrical car manufacturing underestimated the January sales of the car by 20 units, while the actual sales is 120 units. If the manufacturer uses exponential smoothing method with smoothing constant as alpha equal to 0.2, the sales forecast of the month of February of the same year. So very simple problem. Okay, so we know that what will be the forecast for the current month will be your previous month forecast plus alpha times your error, which will be nothing but your demand, actual demand of the previous month minus your forecast of the previous month. So this is what the exponential smoothing will tell us. And you have given what all the information, alpha is equal to 0.2. Okay, only thing is in a slightly it is given for the month of, so t minus 1 is nothing but January and t will be equal to February, that's all, right? So dt minus 1 is how much? January's actual sales will be 120. And what will be of t minus 1? It is saying that it is underestimated. So it was the thing which is there, but we have underestimated that thing by 20 units, which means that t minus 1 will be equal to 100, which means that we have underestimated this thing by 20 units. So we only thought that it will be 100. Okay, so we might have already manufactured only 100 for that, right? But it was coming to be 120, so that you have underestimated by 20 units. So this is the meaning of it. Rest of the things are given. So ft or f February will be equal, forecast of February will be equal to, this is forecast of January will be 100 plus alpha is 0.2 into 120 will be the demand of that thing and minus 100. So 120 minus 100 will be 20. 20 into this thing will be 4. 0.2 will be 4. So it will be 100 plus 4 will be equal to 104. Very simple, right? Right away you can do the answer. Right. Alpha is very low, right? So that you can see that your forecast will be standard to the previous forecast. If alpha was quite high, your forecast will be slanting to the demand side, right? You can say it is more static rather than the small size. So it's a static thing. So alpha is less means it's static. Okay. Now, so this is from EOQ. Okay. So demand of a certain part is, say, okay, I will show it in two ways. So our demand is 10,000 parts per year, and its cost is 1,000 rupees per part. The orders are placed based on the economic order quantity, right? The cost of ordering is 100 rupees per order, and lead time is 5 days. If the holding cost is 20 rupees per part per year,
the inventory level of placing the order, right? So in the EOQ model, we know that it will be instantaneous replenishment, right? So this is our EOQ model, and there will be a thing which is known as reorder level, corresponding to which the lead time is there, right? So lead time is the time which will be taken. If I place the order at that time, it will reach by the end of this one. So this is the lead time between the order placement and the order is getting, right? At that point, what is the order means what is the level is known as the reorder level. Okay, so we will order EOQ. So this is our EOQ. And see, saying that our lead time is 5 days. Okay, so what is our, I will first show with EOQ, right? So what will be our EOQ? Root of 2D CO divided by CH, right? 2 into what is the demand? Demand is 1000 parts. Let me write all the things. Demand is equal to 1000 parts per year. Our cost of one item, C, will be equal to 10,000 per part. Ordering cost, CO, will be equal to 100 per order. Holding cost equal to 20 per part per year. So all the things are in a normal thing. So there is no change in the values because it is given with the actual standard that we want. 2D CO is 100 divided by CH. CH is 20. So 21 0 is gone, 2 is gone. So 4 zeros are there, 2 zeros will come. So this will be 100. 100 will be the ordering amount. Suppose if I order 100, how many orders I have to place? So the total number of parts per year is 1000. So 1000 divided by 100 will be 10. So our N will be equal to 10. So what will be T? Suppose if I take all the 365 days I am working, so you can say that T will be equal to 365 divided by 10 will be nothing but, it will be in days if I want it in days. Otherwise 1 by 10 will give you in a year. If I get 12 by 10, it will be in months. If it's 365 by 10, it will be in days. Okay, so 36.5 will be our total cycle time in days. Right, now our lead time is 5 days. So we know what will be. So if I take like this, so our small demand is D. So what is the D? D is nothing but our total demand divided by, suppose if I want the in days. So what will be D? D will be the consumption, so the consumption rate, right? So that is nothing but D by you can say D by 365 if it's in days, right? So this will be 1000 divided by 365. Okay, okay, or you can say it. Okay, let it be there. Fine. What will be reorder level? Reorder level will be nothing but our LT into D. So D we can find it for this one, right? So multiply with LT. LT's lead time is 5 days, right? Lead time is given as 5 days. Okay, so nothing. So this will be 1000 by 365 multiplied by 5, which will be giving you 13.7. Now you will wonder that why I find out EOQ, right? This is straightly you can give it. Yes, that is true. You can straight away you can find out without using any of this thing. You know that D will be equal to 1000 divided by 365 multiplied by 5 will give you 13.7. Okay. Now if I with EOQ we can find out again D. D will be how much? This will be, what will be this one? EOQ is 100, which is given, right? 100 will be 100 divided by 36.5. Again, it will coming to the same answer, right? This was 1000 divided by 365. It will be the same 100 divided by 36.5. Again, the answer will be same. Another test is there. There is this round off to the nearest integer. This is a typical. So we have to round off. Should it be 14 or should it be 13? Nearest integer is 14, right? Should we go for 14 or should we go for 13? Now what will happen? What is the difference between 13 and 14? So it is not, it is coming to be 30. So the reorder level means 13, which means that whenever my this is 100, we will so in each day it will be reduced, right? In this rate it will be reducing. It will be reduced and reduced and reduced and reduced, and at a point where we will reorder, so that only we will get it by 5 days. So that point is 13.5. So when this 100 reaches 13.77, we will have to order. So 13.75 is a fraction. If it's taken in the integer case, this will be 14. This is 13. So where will we order? Should we order in 13? If we order in 13, what will happen? We will not get it the time exactly here. So some slight offset will be there, right? So for sometimes, maybe not for a day, half a day, we may will not to run the system, right? Because of the shortage will happen. So better we will go for 14. So we can order at 14. So the round off should be even the take it. If you take the nearest one also, it will be 14. But actually, we have to take 14. Okay. Okay. Whenever it reaches 14, you order. Okay. Don't wait for it to come to 13. Okay. Then you will get it by 5 days. Okay. I hope it is clear to you. Okay. Let's go now. Another question from the industrial engineering. So this is our Johnson's rule for which we are scheduling, right? So two machine, n parts, two machine system, you can say. So it's saying that P1 to P7. So 7 parts are there in first machine, first one milling, and then polished with a separate machine. Okay. Using the information in the following table, minimum total completion time required for carrying out both the operations for all the 7 parts. So this is operation 1, this is operation 2. So we can say this is machine 1 and machine 2. Okay. If I want to apply the Johnson's rule, we know we have to have a sequence, right? So in which sequence or what will be the order of selecting this one, right? So we know we will start from, so M1 will be from here and M2 will be from here. So it will come from here to start this one, right? So among these things, what is the least possible time is 1 hour, and that is for P7. So that is coming for M2 machine. So that P7 will come from this one. P7 will be the last thing we will go to process. Now P7 is gone. Now among the rest, what will be the least one? Least one is 2 for P2, and that is also for the machine 2. So P2 will be the second last one. P2 will come from this side, right? P2 is gone. Now what will be the least among the remaining thing? 3, right? 3 is, so 2 is gone, 3. So P3 is corresponding thing. So that's coming for M1. So we will write P3 from here. So P3 will be the first option, first machine. 3 is gone, then 4. 4 is there for 2, right? P4 is there, P6 is there. Anyhow, we don't have a clash because one is coming for M1 and another is for M2. So P4 we will write for this one, and since it's here, the P6 will be from this side. P6 is gone, P4 is gone. Only 2 machines are remaining. So 5 is the next one. So that will be P5. So P5 the 5 is from here. So P5 will be coming here, and then we will process P1. So this is the sequence by which we will do the processing. Now we have to arrange this thing, and also the thing is we have to find out what is the minimum total time for completion of all the jobs, right? So in this sequence we will arrange, and also I have written it in separate one. So I know the sequence of P3, and this will be M1, M2. This will be 4. This will be 6. P5. This will be 5, and this will be 7. P1, it will be 8 and 6. P6, this is 6 and this is 4. P2, this is 3 and this is 2. P7, and this is 2. Where is P4? Oh, P4 I missed. P4 is here. P4, this will be 6, 4 and 6. Oh, P3. Oh, sorry. Slight mistake is happened. P3 will be 3 and 4. P4 will be 4 and 6. Okay. P7 will be 2 and 1. Now we can find out the incoming time and outgoing time. So M1, this is M2. So I will say it is in time and this is out time, and this is also in time and out time. Okay. So at what time we can start P? At 0th time means we can start at P at first go. So it will take 3 hours. So 3 plus 0 will be 3. Now, whenever this machine is free, we can start processing the next one. So I can start only by 3. It will take 4 hours. So it will be completing by 7th hour only. So 7, if I can start working on this one machine. So 7 plus 5 will be 12. It will be free. 12, we can start processing P1. So 12 plus 8 will give you 20 by completing P1. So 20, we can start P6. It will take 6 hours. So it will be 26. It will be completing 26. We can start P2. It will be completing by 29. 29. We can start P7 and it will be completing by 31. Now, what is the case of M2? So M2 cannot be started, means the first we are going to the order, the sequence is same for M1 and M2, right? So we can only start M2 after completing, after all the machining is done. The machining is done, right? Then only the grinding will happen. So that will be, so we can start only by 3. So if I start by 3, I will complete by 7. So here there is no class, we can start at 7, right? 7 plus 6 will be 13. Now only I can start processing, even though my machine 1 will be free by 12, I can only start processing P5 by 13 only, because till 13 my machine 2 will be busy. So 13 I will start here. So 13 plus 7 will give you 20. So 20 is, there is no problem. So 20 we can start. 20 plus 6 will be giving you 26. Right. 26 and 26, no problem. 26 we can start. 26 plus 4 will be giving you 30. Right. 30 and 29, there is a problem. Even though my machine 1 completes the operation P2 by 29, still my M2 is not free till 30. So we can start only by 30. So 30 plus 2 will give you 32. Now 32, if I can, so there's and the same problem happens here. So I can only start by 32. So 32, if I am starting, I can stop by 33. So if my machine starts at 0, I can complete all the operation with the minimum possible time only by 33 hours, right? So the answer to this question will be 33 hours. Oh, your choice is there. So 33 will be the answer, right? I hope you understand this question. Now, another industrial engineering question, which is a simple one from what? From our linear programming. So everything is pretty damn clear because it is given in the matrix form. There is no playing with the lines and we have to interpret from the lines. No, it is very clear. So it is saying that the two products are there, P1 and P2. So provides the 3 materials, M1, M2, M3, and for corresponding manufacturing of P1 and P2, how much M1, M2, M3 is required, that is given. And maximum quantity of M1, M2, M3 is given in this column. And per price, how much I will get a profit from P1 and P2, that is also given. Suppose then we can say that we will produce X1, X unit of P1 and Y unit of P2. Now we can formulate our maximization problem. So it's a maximization problem. It's a profit problem. So maximization of Z, what will be Z? It will be 150 into X plus 100 into Y. This is the maximization problem, and we have to maximize this one, right? What will be the constraints subjected to? We have the limitation of M1, so that if I produce X units of P1, so I have to use 2 units from of M1 from here. So 2X will be the total units which is consumed for P1, and 3Y will be the total units consumed for P2, and the maximum limit is is 70, right? Now this thing will be 2X plus Y less than 50, same way, right? Another thing is 2Y is less than or equal to 40. So these are the constraints. So we have to only solve the problem and find out the maximum profit, right? So three equations are there. We have only 2 unknowns. Okay, so one will be excess, and we have the maximization function like this. Okay, instead of writing this, I'm taking 1 0 away, so that it will be very easy for me to draw. So I will use the means I don't have to go for this simplex table because there is 3 equations, so we have to go for either through 2 or 3 iteration to get the this thing. So graphical method will be sufficient since there is only 2 variables, right? Suppose if I plot the graph, suppose if this is my graph. Okay, the first objective function will be the first function is 2x plus 3y less than or equal to 70. So I will say equal to 7. I will put 0 away. Okay, so this is my first equation. When x equal to 0, y equal to how much? When x equal to 0, y will be equal to 7 by 3, right? No, yeah, 7 by 3. 7 by 3 is how much? 2.33. When y equal to 0, what will be x? 7 by 2. 7 by 2, we know, it is 3.5. So we have the first graph. So let's write the other equations as well. So 2x plus y less than or equal to 5 or equal to 5 level to. When x equal to 0, y equal to how much? 5. When y equal to 0, x equal to 2.5, right? 5 by 2. Another thing is y equal to y equal to 2. This will be a straight line which is parallel to y equal to 2, right? So three equations are there. So I have to go maximum is 5, right? Maximum is 3.5 or 5 only. So 1, 2, 3, 4, 5 in this direction. 1, 2, 3, 4, 5. When you do like this, please try to put that 0 after you complete the thing, right? So that here y means it's the order of similar magnitude, right? So that I can easily draw the graph. That's why I put like this. Okay, 70 also you can find out. So this will be 23 and 35. Okay, that way also you can do the thing. Okay, so only the scaling factor will come. Okay, that's all. So when x equal to 0, so first equation, when x equal to 0, this is x, this is y equal to 3.5. This is 1, 2, 3, 3.5 is here, right? When y equal to 0, x equal to when y equal to 0, x equal to 2.3. 1, 2, 2.33 will be somewhere here. So you can plot a straight line. This is my first line. Okay, now let me take another color. What about the second one? When x equal to 0, y equal to 2.5. When equal to 0, y equal to 2.5. X equal to 0, y equal to 2.5 means here. When y equal to 0, x equal to 5. 5 is this 3, 4, 5. This one. Line like this. And what about the third one? Y equal to 2. Y equal to 2 means it's a straight line parallel to x-axis. Y equal to 2. So this is y equal to 2. Right. Okay. Suppose let me see. Let's assume that it is going to intersect at this point, so that this will be coming, and this will be 1 point, and this will be the third point. This is the fourth point. So there are 4 points of evaluation, right? So this will be 0, 0. Anyhow, we are not going to at that point of time. Our price will be 0. Means our profit will be 0. So what is this point? This will be 0 to what will be this point? So if I put y equal to 2 in this graph, what will happen? That's the point here, right? So solving these 2 lines. When y equal to 2, it will be 2. This will be 3. This will be 3. 3 by 2. No, this will be 2. This will be 3. Yeah. 3 by 2. Or this is the first. This is the second graph, right? Second graph will be x equal to 0, y equal to 3.5. Yeah, that's right. When y equal to 0, okay. This graph I made a mistake. Okay, fine. My second graph is not right. I will erase this also. Okay. What about my second graph? I put the when x equal to 0. This is my second. X equal to 0, y equal to 5. When x equal to 0, y equal to 5 means y should be here. This is my second graph. And when y equal to 0, x equal to 2.5 means this is 2. This is 2.3. It will be coming here. This is 2.33, right? We have found out. So this will be the graph. And the third graph will be this will be y equal to 2. Y equal to 2 graph will be this one. Or did I make the mistake again? This is 2.5. That's okay. When x equal to 0, y equal to 3.5. That is here. When y equal to 0, x equal to 2.33. 2.33 will be just less than this one, right? So only 2 function evaluation we have to have, right?
2.33, 3.5, right? Yeah, in the first graph also I made the same mistake. Sorry. Okay, sorry. When x equal to 0, when x equal to 0, y equal to x equal to 0, y equal to actually, oh, I read it in this way. It is 2.33. This will be 3.5. When y equal to 0, x will be 3. X will be, yeah. So this will be 2.33. 2.33. This is 2. This is 2.33. And this will be when y equal to 0, x equal to 3.5. This is 1, 2. This is 3. This is 3.5. So this will be the graph. Oh, sorry. This will be the graph. Okay. Somewhere it is touching 1. So it will be, we have to solve 1 and 2 to get this point, and we have to solve this 1 and 2 to get this point, and 1 and 3 to solve this point. So what will be, if I put x equal to 2, y equal to 2, it will be 2 into 3, it will be 6. 7 minus 6 will be 1. So x will be 1 by 2. So this will be 0.5. 2.5, right? So this will be, what is this point? This will be 2, 0, or yeah, x equal to 0, 0, 2. What will be this point? This will be 0.52. This will be my A point. This is my B point. This is my C point. So what will be C? C will be solving these two, right? So that you can subtract this one from 2. So 2y will be equal to 2 and y will be equal to 1. Y will be equal to 1. When y equal to 1, it will be 3. 3. This will be 2. Means this will be 4. If I take this y equal to 1, then 3. If I take this side, this will be 4. 2x equal to 4 means x equal to 2. 2, 1. 2, 1 will be the point. And this point will be, we already have this point. This will be 2.5, right? 0, 2.5. No, 2.50, isn't it? How much x will be? X will be 2.5. 0, 5. What is this? Again, a confusion. When x equal to 0, y equal to 5, right? Oh, I have written this way. Okay, when x equal to 0, y equal to 5, and y equal to 0, x will be 2.5. So how much it will be? This point is 0, 2.50. Okay. So for functional evaluation we have to do. So what will be the value? So what is our objective function? 150x plus 100y, 100y. How much will be? When x this is 0, this will be z of a. 0. This will be 2. This will be 2000. Z of b. How much? 0.5 into 150 means 75. 2 into this thing will be why it is 2000 means the x is not 2, it is 20. Now here it is 5 and 20, right? Also I have to do that, means we have to understand that we have scaled into a factor of 10, so we have to multiply the factor of 10. So 150 into 0.5, right? 0.5 is 1 by 2. This will be 75. 750. This will be 20 means 2000. So 2750. Z of C will be equal to how much? This will be 20 into 150. This will be 3000, and this will be 1000 will be 4000. And Z of D will be equal to 2500. No, 25 multiplied with 1500. 150 will be equal to 3750. Okay, so the maximum will happen at this point, so that this will be the our solution. So we will manufacture 2 units of 20 units of if that was us 20 units of x, 20x and 10y is the solution. Okay, and if I do like that, what will be the profit I'm getting? 4000, because this is the maximum among these 4 corner points that we have evaluated. So 4000 is the maximum, so that will be the profit. Now, yeah, it's a multiple choice question since we have the answer here, so this will be the answer. Okay. Orthogonal machining operation. Yes. So in the orthogonal machining operation, cutting force and thrust force are equal in magnitude. So FC is equal to FT. That's cool, right? Uncut chip thickness is 0.5 mm. Shear angle is 15 mm. 5 is equal to 15 degree, not mm. The T will be equal to 0.5 mm. The orthogonal rake, alpha equal to 0. We are very happy. Width of cut, B will be equal to 2 mm. The workpiece material is perfectly plastic and yield at the shear strength tau s is equal to 500 MPa, right? The cutting force it is asked, right? So from the normal formula we can find out what the area of your shear zone, right? It is nothing but T into B divided by sine phi. What is T? 0.5 into 2 sine phi, sine 15. How much? That will be 1, right? 0.5 into 2 is equal to 1 divided by sine 15. 3.86 mm squared. You know towers and AS, you can find out FS, right? FS is something but towers into AS, we know this formula, right? So towers is 50, 500 multiplied by 3.86. This much. This is an MPa. Anyhow, we can use the dimension as millimeter square, right? So multiply with 500 will give you 1931.85 Newton. Okay, Fs is given. Fs is we got Fs. Now, what is the relation between Fs and Ft? So we have the formula. It means different ways you can find out. You can find out the resultant and use the things, and because all the angles are given to you, alpha is equal to 0 and phi is equal to 15. Beta is not given. Anyhow, still you can calculate that Fc when Fc equal to Ft and alpha equal to 0, your friction angle will be the same. So the friction angle will also be 45 degree. You can calculate based on that. Even without that, you can calculate because Fs will be, we know that Fc, right? Now you know that Fc equal to Ft. So this relation is there. So Ft equal to Fc. So that you can say that Fc into cos phi minus sin phi, right? What is Fc? Fc and now what is Fs? Fc will be equal to Fs divided by cos phi minus sin phi. Fs 1931.85 divided by cos 15 minus sin 15, because we don't have to find out any other angles. That's the beauty of this equation. Cos 50 minus sin 15. It is, what is it? Oh, sorry. Minus sin 15. Sin 15 is how much? 2.5. Okay. Okay. Is it 15? Yes, it's 15. So cos 15 minus sin 15 will be equal to this much, and Fs is 1931.85 divided by answer will give you 2732 newtons. 0.04 is there, so we can ignore that then. So 27, rounded to nearest integer, it is 2732. Okay. I don't know whether I have made some numerical mistake here. You can compute the thing and get the right answer if I have made some mistake. Otherwise, you can take it this way. Okay. Moving to the next. Yeah, this is from the metrology again. Pitch circle level. So it's pretty simple question. So if you know, means this is actually the assumptions that we have. This will be, it's not assumption, it's actually to be the, if you use the best square size, this will be 0.5 and this will be 0.25 0.25p when you use the best diameter. Okay, and that's the definition of the best diameter. It will pass through your pitch circle diameter, right? Now, what are the things it is given? Pitch is equal to 4, right? 4 mm.
and it's not saying that it's a single start, it's a double start set. So we'll take it as a single start. And your included angle. Included angle is what? This total 2 alpha will be equal to 60. So our alpha will be equal to 30, right? One angle will be 30. So this is all we want to find out what our best wire size, right? So what will be the diameter of the best wire? So the D will be equal to P sec alpha or P by 2 sec alpha or P sec alpha by 2. Fine. So all be cut. So this will be 4 by 2 into sec 30. Sec is nothing but 1 by cos, right? So 2 divided by cos 30 will be equal to 2.309. 2 decimal places, right? It will be 2.309 mm. If I round off it to 1 place, it will be equal to 2.31 mm. Okay, so 2.31 mm is the right answer. Very simple. So we will use that much size wire to get your pitch circle diameter using the 3 wire or 2 wire method. Okay. Now, the direct current welding process, the power source has an open circuit voltage 100 volt and short circuit current 1000 ampere. Assume the linear relationship between the voltage and current. The arc voltage is V and varies with the arc length L, as V is equal to 10 plus 5L, where V is the voltage and L is in mm. The maximum available power. Actually, for maximum available power, we have a formula. We have P will be equal to max P. P max will be equal to V max I max. This will be happening when V equal. This will be your VOC, open circuit voltage by 2. That will be the maximum voltage we can get, and short circuit current by 2 will be the maximum current we can get. So that this will be equal to VOC into ISC divided by 4. Now this is a simple formula. You can derive it. Means we have the relation between VOC and ISC, right? V by VOC plus I by ISC will be equal to 1, right? So what is power? Power is nothing but P is equal to V into I, right? V into I. Now if I put what will be V in terms of I, so that V will be equal to 1 minus ISC. So VOC will be coming this side. So VOC. So VOC will be multiplied. So I will write VOC into 1, right? Plus what will be the VOC? No, if I take this into, this will be minus, right? Right. Minus VOC divided by ISC into I. This is V, right? If I put that thing in this equation, what will happen? So P will be equal to V will be equal to VOC into this I will come, right? I minus VOC divided by ISC into I will be I square. So this will be the total power equation. We can differentiate with respect to I. So dP by di to get the maximum power, means maximum power. If I differentiate it into 0, what will it? I will the maximum power, right? Corresponding I value I will get if I equate it into 0 and solve this equation, right? So what will happen? So I divide di of I will be a 1. So VOC will be coming this side. What will be happening this side? It will be 2I into VOC divided by ISC. So this will be equal to means equal to 0, equating to 0. So this will go this side. VOC and VOC get cancelled. I will be equal to, we will get that see VOC equal to, I will write it down, 2I VOC divided by ISC. This is what will happen, right? If I take this side. So VOC and VOC get cancelled here, it will be 1. So we can see that I will be equal to what? ISC divided by 2. So this is the maximum I. So this will be the I max for P max. For maximum power, I max should be equal to. So similar way, I'm not doing it. You can put I in terms of VOC and ISC, and then you differentiate with respect to P with respect to V, and you will get the similar thing that VOC will be, means V max will be equal to VOC divided by 2, and that is how you get the formula. So if I put this in this answer, so that will be what is P max will be equal to 1000, that will be I, 100 will be V divided by 4. This will be equal to 25,000, which will be nothing but 25 kilo. This will be involved. That will be same as watt ampere, kilowatt ampere. Watt ampere will be equal to nothing but volt. So this will be 25 kilowatt. Okay, in the integer. I hope you get it. Should I do the other one? This is very similar and very simple. Okay. So whenever you, even with this thing, you can take it for granted, right? Whenever it is giving the maximum power condition, you can say that at the maximum power, your V will be equal to VOC divided by 2, and your I will be equal to ISC divided by 2. Okay. And in this case, you don't require this relation. Okay. Now, another problem, which is not so tricky, but you have to know the concept. Let's go. A cylindrical billet of size 100 mm diameter and 100 mm length is extruded by a direct extrusion process, producing an L section. So L section is given here. The cross-section dimension of the L section is given, shown in this diagram. The total pressure P in MPa is related to the extrusion ratio is Ks in P will be equal to Ks into sigma m into 0.8 plus 1.5 into LNR plus 2 by 2L by D0, right? So that they have find out an MPa relation. That's all. Where sigma m is the mean pro stress of the billet in MPa. So sigma m is the mean pro stress, right? And L is the portion of the billet of length remaining, portion of the billet length remaining to be extruded. Whatever the length which is remaining to be extruded is there. D0 is the initial diameter of the billet. Ks is the die shape factor. Ks is the die shape factor. Okay. The mean flow stress of the billet is given. So sigma m is given, right? Die shape factor is given as 1.5. That is also given. This is also given. Now, maximum force required for extrusion in kilowatt. Maximum force required for extrusion. Okay. To start the extrusion. That is also a catchy thing. So you understand that maximum force is required when at the starting point of this extrusion, right? At the starting point of this extrusion, can you tell me what is L? L is defined as the portion of the billet length remaining to be extruded. At the beginning, at the start of this thing, what will be my L? L will be nothing but length of our extruder, length of our billet. Okay. So that is the time where the maximum force is happening, and that's what exactly they are asked us to find out. Okay. So in this equation, what we have to put L will be nothing but 100 mm. Okay. So that's what you should interpret as the maximum portion at the start, and portion of the billet length remaining to be extruded. Okay. So L we know, D0 we know. These two things are given. Only thing is we have to find out R. What is that R? R is nothing but our extrusion ratio. Can we find out the extrusion ratio? What is extrusion ratio R? It is nothing but the ratios of the areas, right? Area ratio. So this is nothing but A0 by AF, A original by A final. What is the original area? This is our initial billet was of cylindrical shape, right? So what is the area of the cylinder? Pi by 4 D square divided by A final. What is A final? So this area, the area of the L section, right? L section. This is nothing but pi by 4 into D square, 100 square. 100 is the diameter, right? 100 square divided by area of the billet. Let's find out. So suppose if I'm taking cut like this, or you can take a cut like this also. So what is the area of the portion 1 and portion 2? The two portions are there. So what is the area of this one? This will be 60 into 10. So this rectangle 60 into 10 will be the area. Plus second area will be, it will be 10, and this will be 40. 10. So 10 will be gone from here, right? So this is total was 50. So 10 is gone in this one. So that will be 40. So 40 into 10. How much it will be? 600 plus 400. It will be equal to 1000. Right. So divide by 1000. So here it will be 10,000. So 10 pi by 4 is what I get it simply. So 10 into shift by divided by 4. 7.8. So our extrusion ratio is coming to be 7.854. Okay, it's a dimensionless quantity. So all that we require is what we got. But also we have to understand this is the pressure that we are going to find out. We have to convert it into force, right? The extrusion pressure we'll get. We know that when we get the pressure multiplied, the area will give you the force. Which area we have to use? We have to use the original area, right? That's all. Now let's find out P. What is P? Will be equal to Ks. Ks is how much? 1.05. 1.05 into sigma m is equal to 50.8 plus 1.5 ln of 7.854 plus 2 into L is how much? 100 divided by D0 is equal to 100. Right. So let's find out what is ln of. This is coming to be 100 and 100 get cancelled, right? 2. 2.8 in the other way. So ln of 7.8 854 is equal to 2.06 multiplied with 1.5, right? It's 3.09 plus 0.8 plus 2, 5.891. Then again multiply with 50, multiply with 1.05. This will be equal to 309, 309.3. What will be the unit? This is unitless, this is also unitless, and this will be exactly the same unit of sigma, and sigma is in MPa, this will be in MPa. P is given. Now we have to find out what is F, right? F, suppose, yeah, there could be a confusion like you have the formula like F equal to sigma M or sigma average multiplied by epsilon T into A naught. This formula will be quite familiar to all of you, right? Now, if I get this pressure, should I use this epsilon T or should I just multiply with the original area and get this thing? Actually, when it is given as pressure, you just have to use this. You don't have to multiply with your. So that is already being taken care in this. Through this formula, it is already being taken care. So you can directly go for multiplying with P into A naught. Okay. Otherwise, it will be same as that of sigma average into epsilon T into A naught. But we cannot take the directly equation as P into sigma naught, sigma average, because it is given in some other form. Okay, so pressure is given, so multiply with area directly with KT. So this will be 309.3 into pi by 4 into 100 square, which will be equal to into 504 into 100 square will be equal to, it's a becoming big value. And if I take it as a kilonewton, still it is coming to be very big value. This will be equal to 2429.2 kilonewton. So 2429, round off to 1 decimal place. So this is the answer I'm getting. I'm saying that I'm prone to this kind of numerical mistakes in calculating the things. Suppose you can find out whether your answer is right. Okay, some error could be possible. I'm not eliminating all the possibilities of error that's happening through the calculation. Okay, fine. I hope this is slightly thing that you should understand. Only thing is, you have to find out the extrusion ratio. Only you have to find out. The rest of things are given to calculate pressure. Once you get the pressure multiplied with the area, will give you this one. And also you have to you have to read through the lines in the start and length of the remaining extruded below. Okay, it could be first you when you read it, it will be confusing to you. But when you understand, go to the depth of the process, you will find out what is right. Okay. I hope you all get this answer right. Now, I think this is my final question, right? Okay. So a project constitutes of three. This is also a very simple problem, right? It is asking the expected this thing. So it's a PERT analysis and following a beta distribution. 3 times estimates are given optimistic. Most likely at the specific time, once you get for an activity, what will be your expected time? Expected time will be TE will be equal to, you know that, for T optimistic plus T pessimistic plus 4 times T most likely divided by 6. Just use this formula, compute this thing, network, and that's it. So what will be this one? So let me find out T expected time for all these things. So I'm also adding one thing, right? So here is one thing, 1, 2. What will be the expected time for this one? So 5. So here I want to multiply by 4 and add this 2 and divide by 6. So 5 multiplied 20, 20 plus 10, it will be 30. 30 by 6 will be 5. 4 times 3, 12. 12 plus 6, 18. 18 by 6 will be 3. 8 plus 4, 12. 12 by 6 will be 2. 14. 16 plus 8. 16 plus 8 will be 24. 24 by 6 will be 4. Right? What about this one? 4 times 4 is again 16. 16 plus 8 will be equal to 24, by that will be again 4. Right. Now we have this one. Now we have to construct the network. So A does not have any predecessor. So we can start directly A. And what is A? A value is 5, right? And B and C, A is a predecessor, right? Oh, sorry. B and C. So let's just B. B is and C. How much is the values? 3 and 2. B is 3. C is 2. Now D is from C and B and D merge. Okay. Sorry. Okay. D is from C and B and D merges, so that we don't have to close it right there. So this will merge with D to form what? E. So this you can merge it to form E. How much is the values? D. Oh, sorry. D will be 4 and E will be 4. D will be 4 and E will be 4. We have the network, right? So if I 1, 2, 3, 4, 5. So 1 to 5 is our network. How many possible paths are there? So right, this arrow marks. How many possible paths are there? One is A, B, E. Second is A, C, D, E. So what will be the length of this path? 5 plus 3 plus 4. 8 plus 4 will be 12. What about this one? 5 plus 2, 7 plus 8, 15. So 15 is this is the longest path, which we will call it the critical path. So this is the critical path, and length of the critical path will be the minimum duration. And since we are using the PERT experiment, we cannot say that it's the mostly duration, it's the expected duration or expected time for completing the project. So how much it will be there? 15. 15, all the things are in weeks, so that you will say that this is also in weeks. So within 15 weeks, we will complete the project, most likely. And 50% chances are there that we will complete the course, right? Those who know PERTs, those who know PERT in details will get what I mean by 50% chance, right? Okay, now yeah, it's over. So I could able to demonstrate you all the possible answers that can come, but I agree that I'm prone to this numerical mistakes. So the numerical calculations you can go and find it out whether I was right or wrong. Okay, so this was from this thing. Nothing big is there. Only you have to understand certain basics of the thing. From the here, if you know the this formula like Pmax equal to Vmax into Imax, and that will be equal to VOC by 2 and IUC by 2, we will be able to straight away find out the two-wire method. Nothing tricky is there. Only thing is the included angle is given as 60, so that you should understand that your alpha is equal to 30. Its circle diameter is also given. This one from orthogonal machining, very simple, right? This one was a tricky one. So you have to understand the basics of this slab milling operation. Then you will be able to find out. But otherwise, that also the other things are also given, already given. You can be able to find out your Tmax from this equation. Right. The problem from your linear programming, only find out the profit, right? From this Johnson's rule for scheduling. This is also the EOQ thing, very straightforward. Then your computation of your forecasting. Then some electrochemical machining, then casting. Slight problem is there, right? Then CNC, additive manufacturing, metrology, your basics of your iron carbon diagram. It's not iron carbon diagram, your UTX system, the phase diagrams, right? And this is also, you can find it from this other topics for this also. Hope you all get to good scores, right? you have performed really well. You might have performed really well. Others also don't discourage yourself if you are not able to do much performance that you are anticipating to do. That's okay. You can work it out, no problem. Options are still there. Okay, so let me wind up this paper. So I feel that this paper is quite useful to you. Rest of things we will upload very soon. Okay, rest of the portions, the thermal part, your mathematics part, and all. Okay, thank you guys.